In this tutorial, we'll look at how to analyze the distribution of datasets in ArcGIS. In this case, we're looking at two variables, the percentage of Hispanics in a community and the owner occupancy rate of the same community. I have here a shapefile of Massachusetts census tracts acquired from the census, and I've joined to it American Community Survey demographic data for the percentage of Hispanic residents as well as the owner occupancy rate of census tracts. The question is, how do we analyze this data? Well, the very first thing we want to do is we want to get to know our data. Specifically, we want to ask, how is the data distributed? In a GIS context, distribution takes on at least two meanings. The first has to do with geography. Literally, how is the data distributed? The second has to do with the behavior of the values themselves. We'll start with geography since that's the most obvious place. Here we're looking at the distribution, or rather the percentage Hispanic residents in each census tract throughout the state. We can see areas where there are high and low values. To some extent, the borders of census tracts are a little distracting, so I'm going to change the symbology so that we can get rid of that. I'll go to the properties, right-click on the symbol, one of the symbols, and go to properties for all symbols and eliminate the outline. That way it's not distracting. We can actually see the values a little bit better. And so we can see right off the bat that certain parts of the state, there's a few places that have high percentages of Hispanic residents. Immediately Boston, or just north of Boston in East Boston neighborhood, Lawrence, and then we also see Springfield over here and a few other clusters throughout the state, but most of the state appears to have relatively low numbers or low percentage of Hispanic residents. The complication, of course, of looking at data this way is that it's partly affected by the classification scheme that we use. By default, the ArcGIS will go to a natural breaks Jenks method, and when you go to the properties to look at the symbology, you'll see that listed over here in the upper right. That method uses a statistical technique to identify clusters in the data in order to try to identify data that is kind of similar. When you click on the classify button, you'll see how the data is broken up into those different classifications. This is indicated by these blue bars on this histogram. The histogram showing the frequency values that fall in a certain range. So here we can see that values that fall between 0 and just under 7% have the highest frequency of occurrence. So most census tracts have relatively low percentages of Hispanic residents. And in the far end, where you get high percentages of Hispanics, there are actually very few census tracts that have those high values. But what's interesting about the way that these classifications are broken up, you can see that the ranges are very different sizes. And again, that goes back to the method by which these ranges are constructed. A more intuitive way is to use a equal interval where all the ranges are the exact same size, equally spaced, and this is, I think, what most people would imagine. Now, when you look at the data that way, it looks slightly different. We lose a little bit more of the variation. The high spots still stick out to some extent, but most of the rest of the data is completely washed out. Lastly, we could also try another method called Quantiles, in which we have the same number of observations in each classification, meaning that in each range essentially has the same number of census tracts that fall within it, just ordered from low to high. And we can see that the low numbers have a very high frequency. There's a lot of them, and the high that includes a lot of census tracts because there's very few of them. When we look at the data that way, we see an entirely new pattern of data. We still see those clusters, but we see a lot more variation in the middle. And so the fact that you can see this data or look at the same data in three different ways and see three different patterns should make you somewhat critical of the map and not take it for granted what you're seeing. But again, I think we do see some patterns to it. Those certain population centers seem to have high percentages. We can also look at the other variable, which is the owner occupancy rate. And so what I'm going to do is I'm going to copy the layer again, but instead of putting a copy in the same data frame, I'm going to insert a new data frame. And what that does, it's going to allow me to look at the map simultaneously later on in the layout. So I'm going to right click on the layer, copy it, and then click on the new data frame and paste it, and it'll duplicate it essentially, but we're operating two different data frames. I'm going to change the value that we're looking at to the owner occupancy, percent owner occupancy, and it defaults again to natural breaks. And this looks very different from the percent Hispanic. In fact, it almost looks like a mirror image of it. You can see that much of the state has high owner occupancy rates, and there are certain pockets, say again looking at Springfield, looking at the immediate Boston metro area as well as Lawrence, but also other places too. Worcester in the middle, if you know the geography of the state, have relatively lower owner occupancy rates. So that seems to be suggestive. Again, what we'd want to do is we'd want to cycle through different ways of classifying the data to get a sense of how the data looks when we map it differently, because that some of the patterns we think we see might actually be misleading. So again, we'll look at equal interval, and when we do that, a little of the variation is lost again, but we still see some of those pockets. When we look at quantile, in this case, again, more variation, and again, those pockets. So there does seem to be some kind of inverse relationship between Hispanic, percentage of Hispanic residents and the owner occupancy rates, but it's not quite as clean as we might like it, and it seems to vary depending on how we map the data. And that is a central challenge of analyzing data geographically, is kind of coming to a conclusion or getting a clear sense of what's going on between these two sets of data that occupy the same geography. So, but again, we're still trying to get a sense of the data itself. So this way of looking at it, of identifying or looking for geographic patterns, of identifying where in the state high and low values are occurring, is definitely an important starting point. But the other way that we look at data distribution is to look not at the geographic pattern, but to look at the behavior of the values themselves. And this is kind of a conventional statistical method of looking at our data. You'll notice that when we go into the properties for a layer to change the symbology, and we go to the classification method, you are presented with this nice histogram that shows you the distribution of the data in the way that we're thinking about in the second sense. And here you can see that for the owner occupancy, the high frequency of census tracts with high values, and the relatively interestingly lower frequency of census tracts that have low owner occupancy rates. You also get some of the basic descriptive statistics in the upper right corner here. But I want to actually show you another tool that accesses the same kind of statistics in a little nicer way. So when you're interested in looking at distribution data, you can use a set of tools called Exploratory Spatial Data Analysis tools, but they require the Geostatistical Analyst extension. So under the Customize menu bar, you want to check your extensions, and you want to make sure that this Geostatistical Analyst is turned on. Once that's on or checked off, you can right-click on the upper bar here, and then activate the Geostatistical Analyst floating toolbar. And what this will do is give us access to a lot of really neat tools. So from the Geostatistical Analyst floating toolbar, we'll go to Explore Data, and the first thing we'll look at is again a histogram. And so this histogram pops up with a floating window, and in the lower part of the window is where we specify which variable or attribute we want to see. So again, here we're going to start with the owner percent owner, which is the owner occupancy rate, and you see right away the distribution of the data again on a familiar histogram. The nice thing is this histogram, you can control how many bars or the way the data is broken up. And again, just to clarify what we're looking at, this histogram shows us the frequency of different occurrences of value. So this bar over here on the far left, the way that we read it is that the number line along the x-axis, as it were, tells us the data values, meaning the owner occupancy rate, and the numbers along the y-axis here tell us the frequency, or how many occurrences there are of that. What you pay attention to too is the power over here, so it's 10 to the power minus 2, which is to say that you actually have to move the decimal point over 2 spots in order to get the actual number. And same thing down here, 10 to the negative 2 means you have to move it over 2 spots. So what it means in a practical sense is that about 56 census tracts have values between 0 and 10% homeowner occupancy rate. So very few, because there's actually, if you paid attention earlier, about 1,400, actually you can see it up here in the count, census tracts, very few have such low occupancy rates. So as we saw on the map, most parts of the state actually have pretty high owner occupancy rates. And on the far end over here, we can see that something like 150 or so census tracts have owner occupancy rates that are between 90 and 100%. Now, what's really neat about this particular histogram, that's unlike the one that you see when you look at the properties, is that if you click on the bar itself, you'll see the corresponding census tracts that fall in that number range highlighted on the map. And you can do that with every bar. You can do several at a time, and you'll see where those fall. And this is a really powerful way of exploring your data, because in addition to seeing the distribution of your data, you're also seeing how that relates to its geographic distribution too. So you're getting two things at once. The first thing to observe, though, just from a very conventional statistical sense, is that with the distribution of owner occupancy rates, you can see that it's negatively skewed, which is to say that the data kind of spreads out thinly in the left-hand direction toward the lower values, while the majority of data, the higher frequency of occurrences, are actually kind of clumped over here toward the right. Now, the significance of that is that, one, it's very different from what we call a normal distribution. A normal distribution is a situation in which most of the data is kind of in the middle of possible values. You know, you get very few on the low end and very few on the high end, and most are somewhere in the middle. And it's kind of a starting point, an assumption about how you expect data to behave. It's also important, though, from a statistical perspective, because there are a number of statistical tests and other processes that assume or need to have the data in a normal distribution. If it's not, you'll have to actually make accommodations or actually look for different tools. But in any case, it's a way of describing what's going on with the data. So, and it's apparent from the map itself that large parts of the state have very high percentages of homeowner occupancy. We can see that reflected in these descriptive statistics in that little box. We see that out of the 1,471 census tracts, there are some that have 0, meaning no owner occupancy, and some that have 100% owner occupancy. The average is about 60. The mean or average is 60%, which would fall right about here. But notably, the median is 65%. The median meaning just the middlemost number among from high to low. And 65, you'll see, is right here, and they don't line up, mean and median. And the reason for that is the mean is kind of pulled to the lower end by the fact that you've got values so far to the left. We say that the data here is skewed negatively, as I said earlier, and the skewness is reflected also up here in a slight negative number, and it's just an indication of the fact that the data is kind of being pulled to the left here. The kurtosis is also kind of is a descriptive statistic showing you indicating the symmetry of the data. So if it was symmetrical about the mean, meaning that the data was equally distributed on the left and the right of the mean, then we would have a kurtosis of something like 3. But the lower end tells you that it's, again, pulled over. So they're kind of not redundant, but they're repeating or kind of reflecting the nature of the data. Lastly, of course, standard deviation is telling us the level of dispersion about the mean. So the mean, again, falling about right here would be the average, but the dispersion is pretty significant. So one standard deviation represents the data that falls within about 70% of all values fall within one standard deviation generally. And you can see that in order to capture that 70%, you have to go pretty far out in both directions. So the data is fairly dispersed. So there's a lot of, not scatter, but dispersion around there. So all of that is to say that, this is what's going on with the data. And what's interesting about that is it's going to be very different, or it could be very different. So when we look if we switch over to percent Hispanic, we'll see there's a very different distribution compared to owner occupancy. And so if we switch back on our activate the other data frames, we can look at that for a second. We can see that almost inversely compared to the owner occupancy, the percent Hispanic residents, most census tracts have very low numbers. And again, we can click on that bar and we can see that, oops, because I'm in the wrong layer. So actually, let me go back to the, because we were working off of that layer. There you go. You can see that the distribution. I'll have to switch to percent Hispanic. Here we go. Okay. So you can see that the vast majority of census tracts have very low numbers. So we see that over 1,200, almost all out of the 1,400 have values that fall somewhere between 0 and about 10%. And then again, it's only when we go to the far end over here where you have values above, say, 76%, you're looking at only a small subset of census tracts that have these values. And again, there's concentrated in the Springfield, Boston, and Lawrence area. And those of you who know the state, that may not be entirely surprising, but it kind of confirms that. So notice too that this data distribution for the percent Hispanic is not normally distributed. So the data is not evenly distributed around the mean. In fact, this is highly positively skewed in this case, because we can see that although we've got this big clump of high frequency of values on the low end, the values actually extend far to higher numbers. So you get a real wide spread, and it tends to be biased toward that higher positive end. So then you see the number is reflected there. You can also see that there's a significant difference between the mean and the median. The mean being on 11% would place it about right here. That would be the average value, while the median is actually far over here, and that's because, again, the mean gets pulled by those higher or more extreme values that are in the data set. So we also see a higher standard deviation, which means that there's a lot of dispersion around that mean because the data is very distributed or highly dispersed. So there's a lot of variation within the data set, and is not normally distributed. So at the very least, what it tells us is that there's only very few places that have high values and a lot that have low values, but there's a big spread, and we see that the data distribution is very different between the the owner occupancy rate and the percentage of Hispanic residents. So that's a good starting point, because it tells us, when we're looking for similarities or differences between the data sets, we see there's a lot of differences. But it doesn't necessarily tell us whether or not the data is related or there's something else going on between them. It does, as we noticed earlier, suggest that there is something of an inverse relationship, because it does appear to some extent that the places that have high values in one have low values in the other, and it also seems that the data sets seem to have opposite distributions. Again, when it comes to the percentage Hispanics, we see the bulk are low values that tend to be very spread out, with the high values very few and concentrated. And it's the opposite situation when we look at the owner occupancy rate, although the owner occupancy rate isn't quite as skewed as the percentage Hispanic. So some interesting differences and similarities and inverse or mirror images between the two data sets. Last thing is we can bring this, the nice thing about these histograms is we can bring them into our layout. So if we want to add this to the layout, and it's kind of nice because we have the histogram built and we also get these statistics, we can click Add to Layout, and we'll see that in the layout we have now, I'm going to get my layout tools again, we have two data frames. We've got the one showing the percent Hispanic, one owner occupancy. So let me make sure that we're looking at the same thing here. So this is owner occupancy in the lower one, so we don't get them mixed up. And we can compare that to, oops, I will get this eventually. Let's do this. Okay, good enough. So we see here, we see the owner occupancy and we see percentage Hispanics above it, two different data frames. The histogram that we created over here is for owner occupancy, and so it's nicely formatted with the statistics for that particular map, and we can do the same thing for the percentage Hispanics. We'll just again generate that histogram, specify that that's what we're looking at, and then again add that to the layout, and then we can have the two graphs right in there, and it gives us a starting point for comparing the two data sets.